Hey there, I'm Soumya Shah, and I have participated in the Hackathon 2024 organized by Giant Alert Group of USA. And I recently graduated from Michigan State University, and I'm a data scientist by profession. So I have tried to work on this problem statement and come up with a really cool solution. So I knew that 7 days is not enough for participants to do everything. So me being from data science and statistics and AI background, I don't have much experience with the software development background. So I tried to collaborate with a few other teammates, a few other participants of the hackathon, and try to come up with the solution. It gave me a new perspective to the problem statement. And well, our tech stack includes Python predominantly used by me for scripting, and then AWS RDS for hosting our MySQL database, and then Docker for containering the whole application, React for building the UI, the front end, and Flask and Fast API to and Node.js to run the backend, Selenium for web scraping, and GitHub for obviously for version control. So when I started off with this hackathon, and it was a complete mess. We could not figure out what to do. All the participants weren't able to figure out what to do, and I thought that see there are I was in a dilemma that there are three main ways through which I could find data. One was through get by getting an API access. Another was getting through unregulated unregulated platforms and open source platforms like Kaggle. And then the third option was to do go completely hard on scraping the data, like from Zillow, Redfin, Realtor, Homes, and Apartment.com. So it was a pretty tough decision for me to gather resource, and I came up with a solution that I want to go for web scraping from all those websites, because I care about accuracy. When I say I care about accuracy, I have reasons for it. Uh, any, I can build any prototype for any kind of hackathons for just by using REST APIs. But the thing is, the third party who provides me all that data can anytime revoke my access. And then the thing is, my prototype can't be scaled into a big large solution. I need to have my own sources of data. Well, we can't go on ground and annotate it or get access from MLS. Then the only solution we have is to get the data scraped. Well, there also lies a very important decision, that not scraping from bigger websites, bigger as in more famous website. What do? Is they get their own data from third-party sources. So what happens that we are if we scrape data from more famous websites, what happens is that we get data which is provided by third party, which is transformed, and then we scrape that data for more transformations. So it is transformations over transformations, and it is extremely becoming extremely complex. And we all know what happens when some things are over transformed. They become rubbish. They are not useful. In statistical terms, they lose their identity. When I say identity of data, I talk about four types, four things, four moments. We say them four moments of the data, like mean, variance, uh, standard deviation, and skewness and kurtosis. So all these things matter a lot when we want to provide a data driven solution. Next is reliability. All my code is, if you check out my code, all my code is well written with better coding practices, has retry mechanisms, and has consistent exception handling. So whenever if my scraper goes out for scraping from different websites, if the sites are unresponsive, it tries again and again, and if like there are maximum 3 tries, it just jumps off to the next web page. And this scraper I specifically coded it in such a way that it can be modular and it can act as a plug and play device. Like if we want data from Redfin, here we go, we have that from Redfin. If we want data from Marcus Millichap, we just have to change the IDs and classes of the web page, and then we are ready to go. Next, efficiency. Efficiency matters a lot. When we say that we are real time, a real time solution, and when we say we that we are scraping things and bringing alerts in real time, it has to be extremely efficient. So I tend to do that using asynchronous processing. And we all know that time complexity matters a lot, and that's why I tried to implement hashing and modular programming. Hashing all the data gathered from the scraper is staged first in the MongoDB data database, and it is done so that and not directly used for UI, and it is not directly used as a SQL data. And the reason is to maintain an abstract data layer and to provide extra layer of security to the data itself. So what happens that if someone attacks, does SQL injections, or does or through backdoor violates our security, so that could literally expose our scripts of scraping, and that could expose our sources. We don't want that. That's why we have to stress on efficiency. And that's why if you see my database design, it is a 3NF database design. This is my system design. First, it scrapes the data from all this website. Then the Selenium bot goes to Mongo, like takes the data to MongoDB staging database. And then I have coded an analytics script, which like MongoDB has all sorts of data, and it is all raw data. It is in the text form. I have to convert it into other forms so that it is accessible to store perfectly in the required format in SQL. So I wrote an analytics script which is run on Docker, which continuously does the same thing like a Selenium bot. The moment it continuously runs to fetch new data, and the analytics script continuously run to check whether there are new data points in the MongoDB, and then it pushes the data, the transformed, the analyzed data into the AWS RDS MySQL. As I said, I primarily I don't come from the background of software engineering. I got help from Bhavik Shah and Minal Kyada. Both of them are software developers, so they helped me build the UI for this app. So Bhavik Shah worked on the back end, and Minal worked on the front end, and they both created a really good UI. So what happens that when I gave them access to the AWS, they got the data from AWS, and then they integrated the database and the front end and the back end, and then we all of us built Docker Docker images to run the whole data, to run the whole scripts onto the Docker engine, and then this thing has enabled real-time success. So here comes the cool part. When we say the data analytics and things, like whenever we go to buy a house or for investment purposes, there are a few things we stress a lot. Those things are like climate risks, crime, things like availability of trails for, like, people want trail or better flora and fauna around their places for jogging or cycling or biking or riding, something like that. They also want transit facilities. Connectivity matters a lot. So instead of getting those data from some third party API, which is questionable, I got all those data from US government websites and US like published data sets. And we got all those information based on pin code, and then created my own metrics. Like, I created scores for each one of them, like, for example, number of schools around this locality. Schools matter a lot because number of schools have indication about all the entertainment industries. Like, they have movies, they have restaurants, they have, if they have all those things, they have playgrounds and rest and all the other things. Similarly, there are risk factors which people consider a lot, like sinking shoreline. Those things matter a lot. So, or tornadoes or hurricanes, and extreme crime zones like thugs, thefts. These things matter a lot. So here's a continuous market scanning demo. This is how my scraper scrapes the data from different websites. The data, it's a data-driven solution. It's most important thing. Good quality data is most important thing for the entire solution, for the 6 module solution. Okay. Next thing is dynamic data integration. So as I said, like, this is how it looked in MongoDB, and this is a screenshot of AWS, my AWS dashboard, and this is how this is my SQL workbench. I connected it to the AWS RDS, MySQL instance, and this is how it looks. And the real-time property scoring. So so this is how I generated metrics for safety, for school counts, sidewalk score, transit score, and weather score. And I also tried to fetch what kind of weather risks are there in this thing. And Minal did an absolute job on putting it onto UI. She created a PDF report. So our backend and front end works in such a way that whenever a person clicks on a house, that house generates that it generates a report which contains all this data. Next directions, future directions. Well, it was the whole hackathon was an amazing experience. I got to connect with some brilliant minds, and we worked together and did amazing, cool stuff, and produced legit results. And so next steps for me, it would be financial underwriting. It's heavily data science intensive um, work. It needs personalized real estate AI I can do it using a personalized real estate AI recommendation system, which is run based on the scores and the metrics which I created, along with the personal information of users, like what tax range they are, like what pay range do they get, what is the fixed term fixed limit they wanna get the mortgage, and what is the repo rate, and based on that we can calculate the mortgage, the payment, and obviously down payment, and all those questions we can ask from the user. And what we can do is provide a solution um, which suggests particular property listings which are perfectly matching their profile. And we can create an alert system or something like that, that whenever the module 1 and module 2, it is working on, it is running continuously. So whenever there is a listing which matches the profile of the person, that person gets a alert on his or her phone or email or something like that. and it provides financial assistance, or like how to apply the loan, or how to apply for mortgage, something like that. That's all. Thank you.